In this video, we want to learn about adding, subtracting, multiplying, and dividing rational expressions. Let us start with this example. 6x over x to the 2 minus 9 times by 4x plus 12 divided by 3x. For multiplying rational expressions, simply we multiply the numerator by numerator and denominator by denominator. For example, suppose we want to multiply a over b by c over d. We multiply numerator by numerator and denominator by denominator. But before doing this, first always we check if we can factor and simplify numerator with denominator. So first we try to factor numerator and denominator. Here in this example we have 6x over this expression in the denominator can be factored as x minus 3 times x plus 3. How we can factor this? Let me remind you identity a to the 2 minus b to the 2 is a minus b times a plus b. Based on this identity, x to the 2 minus 9, which is 3 to the 2, can be written as x minus 3 times x plus 3. So we can factor the denominator in this way. For the other fraction, if you pay attention to the numerator, we have 4x plus 12. From 4x plus 12 we can factor 4 and then we have x plus 3. If we multiply 4 in the bracket we have 4x, 4 times 3 is 12, same expression, all divided by 3x. Now look at the numerator and denominator and try to find common factors and cancel those factors from numerator with denominator. X plus 3 with x plus 3 cancels. If you pay attention, in numerator we have x, in denominator also we have x. So this term cancels with this term. Also in numerator we have 6 times 4 because we multiply the terms in numerator. 6 times 4 is 24. Divided by 3 would be 8. Basically, you can simplify this in this way. 6 divided by 3 would be 2. So we simplify 6 with 3 in denominator. 6 divided by 3 is 2 and we have 2 in numerator. Now in the numerator we have 2 times 4 which is 8. So the final answer is 8 over, and in denominator we have only x minus 3. 8 over x minus 3. This is the final answer for this question. Now look at this example. X to the 2 minus x over 2x plus 2 divided by 3x minus 3 over x to the 2 plus 5x plus 4. To divide two fractions, we multiply the first fraction by the inverse of the second fraction. This is the way that we divide rational expressions. Suppose we want to divide a over b by c over d. Instead of dividing a over b by c over d, we multiply a over b by the inverse of c over d, which is d over c. Basically, we switch the numerator and denominator. Then we multiply a by d and b by c. So the answer is ad over bc. But as usual, always we have to check if we can factor numerator and denominator, because it makes calculation easier. If you pay attention, x to the 2 minus x can be factored as x times x minus 1. In these two terms, we have x as the common factor. So we factor x and then we have x minus 1. For the denominator, we can factor 2. And if we factor 2, then we have x plus 1. We want to change division to multiplication. So we have to move this to the numerator and we move numerator to the denominator. So here we have 3x minus 3 in the denominator. But we can factor 3 from these two terms. And if we factor 3 from these two terms, we have 3 bracket x minus 1. If you multiply 3 in the bracket, again you have 3x minus 3. And we have to factor the denominator and move it to the numerator. But how we can factor this? X to the 2 plus 5x plus 4. For factoring trinomials like this, when the leading coefficient, this coefficient here is 1, we put two brackets, and in each bracket we write x. Then we look for two numbers that their product is 4, their sum is 5. What are the numbers that their product is 4, their sum is 5? The numbers are 1 and 4. 1 times 4 is 4. 1 plus 4 is 5. This is the way we factor these polynomials, these type of trinomials basically. So the factored form of the denominator, the factored form of this expression is this, which we have to write it in the numerator. Because attention, we change this division to multiplication. So we invert the second fraction. Now look at the numerator and denominator and try to find common factors and cancel common factors. X minus 1 with x minus 1 cancels. X plus 1 with x plus 1 cancels. And we don't have any other common factor between numerator and denominator. So in numerator we have x times x plus 4, and in denominator we have 2 times 3, 2 times 3, which you can write as 6. And you don't need really to multiply these two by each other. You can leave it this form. If you like, you can multiply x in the bracket, but it's not really necessary to do this here. And this is the answer of this division between two rational expressions. This is another example of dividing two rational expressions. X to the 2 minus x minus 6 over x to the 2 plus 2x. We can factor this trinomial again. In this way, we put 2x in each bracket, x in each bracket. Then we look for two numbers that their product is negative 6 and their sum is negative 1. Two numbers that their product is negative 6. The numbers can be negative 1 times 6, negative 2 times 3, or negative 3 times 2. If you pay attention, negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. So the numbers that we are looking for are negative 3 and plus 2. X minus 3, x plus 2. For the denominator, if we factor x from these two terms, then we have x plus 2. Then we invert this. So we have to factor this denominator and move it to the numerator. What is the factor form of this? We can factor from these two terms x to the 2. And then we have x plus 1. What is the factored form of this? What? The factored form is x in each bracket, two numbers that their product is negative 3, can be negative 3 times by 1 or negative 1 times 3. Between these two pairs, this is their answer. Negative 3 times 1 is negative 3. Negative 3 plus 1 is negative 2. So the factored form is x minus 3, x plus 1. Again, we look for common factors. X minus 3 with x minus 3 cancels. X plus 1 with x plus 1 cancels. X plus 2 with x plus 2 cancels. And x to the 2 from numerator with x from denominator. X to the 2 basically divided by x is x. So the answer is x, because we cancel 1x from x to the 2 because x to the 2 is x times x. 1x from this cancels with x here, and 1x remains in the numerator. So the answer is x over 1, or simply x. Here in this example, we want to add two fractions, two rational expressions, 1 over x plus 2 plus 1 over x minus 2. For adding rational expressions, we have to make the denominator the same. We have to find the least common denominator. So don't make this mistake to add numerator to numerator, denominator to denominator. To add two rational expressions, the denominator of the rational expressions should be the same. Then we add the numerators to the numerators. By looking at these denominators, we notice that the denominators are not the same. Here we have x plus 2. In the other denominator, we have x minus 2. To make the denominators the same, we have to multiply the denominator of this fraction by x minus 2. And of course, because we multiply the denominator by this expression, we have to multiply the numerator, of course, by that expression, because we don't want to change the value of the rational expression. So this is the way that we do these questions. We multiply the numerator, which is 1, by x minus 2, and we multiply the denominator also by x minus 2. Attention, this x minus 2 with this x minus 2 can be cancelled, and this is like a 1. And multiplying by 1 doesn't change the value of anything. That's the reason we multiply numerator and denominator by x minus 2. For the other fraction, we notice that here we have x plus 2. We don't have this factor in this denominator, but the least common denominator should involve all the factors of all the fractions. So we have to multiply the denominator and numerator of this fraction, this rational expression, by x plus 2. So we have 1 times x plus 2 all over x minus 2 times x plus 2. Attention that you don't need to really write this 1 here or this 1 here, because 1 times y anything is the same thing. But here I wrote the 1 because I want to show that we multiply the numerator and denominator by this expression. Now, if you attention, the denominators are exactly the same. We have x plus 2 here, also we have x plus 2 here. We have x minus 2 here, we have x minus 2 here. And the order of the brackets is not important. So the denominators are the same. When the denominators are the same, simply write one of the denominators, because they are the same. Just write one of them and add or subtract numerators by numerator. In the first numerator, we have what? We have x minus 2. What we have in the other numerator? X plus 2, because 1 times x plus 2 is x plus 2. Simplify numerator. In numerator, we have x plus x, 2x, minus 2 plus 2 cancels. This cancels with this. So this is the final answer for this question. And please attention, here in the denominator, should we multiply these brackets by each other? No, it's better to leave it in the factors form. There is no reason to really multiply the denominator by denominator. So it's not a good idea to multiply these by each other. Leave it in the factored form. But it's not wrong to multiply them by each other. Now look at this example. 2 over x plus 3 minus 1 over x to the 2 plus 7x plus 12. The first rational expression is a simple rational expression, so we leave it. But this other one is a little complicated. In the denominator, we have a quadratic, and we know that usually we can factor quadratics. We put 2 brackets and we try to find two numbers that their product is 12, their sum is 7. Those numbers are 3 and 4, because 3 times 4 is 12, 3 plus 4 is 7. So this is the factored form of this trinomial. If you wonder why we have to factor, why we cannot directly find the common denominator, yes, of course you can multiply this denominator by this denominator as the common denominator, but attention, it's better to find the least common denominator. And for finding the least common denominator, you have to try to factor the denominators. Then clearly you can see the factors of the denominator. But in this original form, it's not clear that here in this expression we have that factor. But when we factor this, we can see that in this expression we have the other denominator. So factor the denominators first, then make the denominators the same. In the second denominator we have x plus 4, but we don't have that factor here. So what we have to do, we have to multiply the numerator and denominator by that factor, because we want to make the denominators the same. So we multiply the numerator and the denominator by that factor. Now as you can see, the denominators are the same, and for the other fraction, for the second rational expression, we don't need to do anything, because already the denominator involves every factor. Compare the denominators, they are the same. Now we write one of the denominators and we simplify numerator. In numerator we have 2x plus 8 minus 1. 2 times x is 2x, 2 times 4 is 8, and don't forget it's minus 1 because we have 1 to subtract. Minus 1. 2x plus 8 minus 1 is 2x plus 7. So the final answer is 2x plus 7. 2x plus 7 all over x plus 3 times x plus 4. This is the final answer for this question. Now look at this example. 2x plus 1 over 2x to the 2 plus x minus 15 divided by 6x to the 2 minus x minus 2 over x plus 3. We know that for dividing two rational expressions, we multiply the first rational expression by the invert of this. The thing that makes this question a little challenging is factoring these trinomials. So we have 2x plus 1 over this trinomial, but we know that we have to simplify the trinomials because simplification helps to figure out the factors, and then probably we have common factors, we can simplify the rational expressions. So we try to factor 2x to the 2 plus x minus 15. Whenever we have trinomials that the leading coefficient, this number here, is other than 1, like this example, the method of factoring these type of trinomials is that multiply this number by this constant. Here we have 2 times negative 15, which is negative 30. Let me show you the process for the other trinomial that here we have. If we want to factor 6x to the 2 minus x minus 2, we do same process here. We multiply this 6 by this negative 2, which would be negative 12. So as you can see, the process is exactly the same, and I want to show you that nothing changes in this process. The examples are different, but the process is the same. If you learn one of them, you can do any other question. Now we are looking for two numbers that their product is this and their sum is this coefficient, which in this case is 1. Here we are looking for two numbers that their product is negative 12, their sum is negative 1. So we want to find two numbers that their product is negative 30, their sum is 1, because this coefficient of x here is 1. Those numbers that their product is negative 30, their sum is 1, are the numbers are 6 and negative 5. 6 times negative 5 is negative 30. 6 plus negative 5 is 1. But how we use these numbers? Are we going to put brackets like before x in each bracket? No. The way that we want to use these numbers is a little different. Please pay attention. Now we are going to write 2x to the 2. Now we want to write this middle term x in the form of combination of these two numbers, in the form of 6x minus 5x minus 50. And attention, it doesn't matter to write negative 5x first, then 6x. It's up to you. So the way that we use these numbers is that we want to split this middle term and write it in the form of 6x minus 5x. Let me show you how we use this for the other example. So you can see it's exactly the same. Now here we are looking for two numbers that the product is negative 12. Their sum is 1, negative 1, because it's negative x. Those numbers are negative 4 and 3, because negative 4 times 3 is negative 12, negative 4 plus 3 is negative 1. So here, 6x to the 2, we write negative x in the form of negative 4x plus 3x minus 2. Now what we have to do after? After that, we consider these two, and these two as groups. And we try to factor them, the common factor. What is common factor between 2x to the 2 and 6x? 2x. Then we have x plus 3. What is common factor between negative 5x and minus 15? Negative 5. And then we have x plus 3. Let's do the same thing for here. 6x to the 2 minus 4x. What is common factor? 2x. And then we have 3x minus 2. What is common factor between 3x minus 2? Nothing. There is no common factor between 3x and minus 2. So we leave it as 3x minus 2. It's not a bad idea to put a bracket for that. Now look at here. We have x plus 3 common between this term and this term. And exactly same thing here. 3x minus 2, 3x minus 2 common factor between this term and this term. So we factor that common factor. Then we have x plus 3 times by 2x minus 5. For this one, we have 3x minus 2 as the common factor times by 2x plus, here we have a 1, you can call it the plus 1 times this, plus 1. And as you can see now, these trinomials is factored. So the process is exactly the same. Now that we have factored these trinomials, we can use them for our question. For the denominator, we have x plus 3 times by 2x minus 5 multiply by, don't forget we want to invert this, so we factor this and we move it to the denominator. So in denominator we have 3x minus 2 times 2x plus 1. And for numerator we have x plus 3. So this denominator goes to the numerator x plus 3. After factoring numerator and denominator and doing these, the story is very simple. Simplify. 2x plus 1 with 2x plus 1 cancels. X plus 3 with x plus 3 cancels. And we are done. In numerator, we have basically 1 times 1. When you cancel this, a 1 remains here and a 1 here. 1 times 1 is 1. So numerator is only 1. And in denominator, we have 2x minus 5 times by 3x minus 2. Before I show you the next question, let me tell you something about the technique that we use for factoring these two trinomials. In different textbooks, you can find different methods for factoring trinomials like this when the leading coefficient is not 1. I highly recommend you to learn only one method and do not change your method from one question to the another. Use one method, and this method that I showed you in these examples is probably the best method that you can learn for factoring these type of trinomials. Because this method that I showed you is based on the grouping, which is very good technique for factoring expressions. Now look at this example. Here we have a compound fraction, or basically like a complex fraction. 1 plus 1 over x divided by 1 over x minus 2. If you wonder why I'm saying divided, whenever we have a fraction is like a division. When you say 1/2, 1/2 is basically 1 divided by 2. Keep this in your head. This is the meaning of a fraction. For simplifying compound fractions like this, you can use two methods, and here I will show you both methods. It's up to you to choose between these two methods. Both of the methods are very effective. Sometimes maybe one of them is better than the other one. So it's not a bad idea here to learn both methods. Let me show you how we can do this question. For simplifying this compound fraction, you can start by adding these two and subtracting these two. Then divide the numerator by denominator. This is one way. The other way is to try to get rid of the denominators. So the other method is to try not to add or subtract the numerator or denominator. Is to try to get rid of the denominators. Then divide numerator by denominator. First, I'm going to show you the method that we want to get rid of the denominators. We want to eliminate the denominators. If you pay attention, in numerator and in denominator, the denominators are the same. So here we are a little lucky because the denominators are the same. So we want to eliminate x. We want to get rid of x. How we can get rid of x? When you have an x in the denominator, how you can get rid of that? Of course, by multiplying by x. Suppose you have 2 over 3. How you can get rid of these 3? If you multiply by 3, 3 with 3 cancels. But we know that we cannot simply multiply by something because it makes no sense. But attention, here we can use a trick. We write the numerator and we write the denominator. We multiply at the same time. This is the technique. We multiply at the same time the numerator and denominator by x. This doesn't change the value of the rational expression, because when you multiply at the same time the numerator and denominator by something, because these two can cancel each other, so this is like 1, and multiplying by 1 doesn't change the value of the original expression. So this is completely mathematically right to do this. So we multiply numerator and denominator by x. Why we multiply by x? Because the denominator is x. We want to eliminate x, so we multiply numerator and denominator by x. Now start multiplying x in the brackets. Then we have, if we multiply x in the bracket, x times 1 is x. X times 1 over x, x with x cancels, 1 over x times x, x with x cancels, and only we have 1, so plus 1. This is for numerator. What about the denominator? In denominator, x times 1 over x, again x with x cancels, we have 1, minus x times 2 is minus 2x. And this is the final answer of this question. So the answer is x plus 1 over 1 minus 2x. Now let me show you another method for simplifying this compound fraction. Here we are not going to eliminate the denominator. First we try to simplify numerator and denominator. In numerator, as you can see, we have an addition. We want to add 1 to 1 over x. For that we have to do a common denominator, a least common denominator. So we have x as the common denominator. The denominator of this rational expression is x, so we want to make the denominator of this one also x. And attention, 1 is like 1 over 1. Because the denominator of this first term, which is 1, is just 1, but we want x, so we multiply the denominator and numerator of this rational expression by x. So we have x over x. Attention, x over x is 1, and we want to have 1 plus 1 over x. So x over x is 1, and 1 over x is the second. Now the denominators are the same, so we have x plus 1 over x. We write one denominator and we add the numerator. Let's do same thing for the denominator. We do a common denominator in denominator. Then we have 1 over x minus 2x over x. We multiply numerator and denominator by x. Then we have 1 minus 2x over x. As you can see, this x plus 1 is appeared. 1 minus 2x is also appeared. And it seems that this x with this x cancels and we have same answer. Now we have a rational expression divided by an irrational expression. We know that for dividing rational expressions, we write the first rational expression, which is the numerator, and we multiply it. This is division. We multiply it by the inverse of this. So we multiply by basically reciprocal of 1 minus 2x over x. So we multiply it by x over 1 minus 2x. X with x cancels. This x with this x cancels, and the answer is x plus 1 over 1 minus 2x. Here in this example, maybe you think by yourself, the first method was better than this. In this example, completely you are right. But not always the first method is better than the second method. It depends to the questions. So it's better for you to learn both of these methods, and depending on the question, you can apply the appropriate method to solve the question, to simplify the expression. Now look at this example. 1 plus 1 over x plus 1 divided by 1 minus 1 over x plus 1. We have a compound fraction. Again, if you notice, the denominators are the same. So probably the better method that we can use for this question is also multiplying the numerator and the denominator by an expression that can help us to eliminate the denominators. What is the denominator? The same. So we multiply only the numerator and denominator only by x plus 1. Let's see what happens by doing this. Then we have x plus 1 times 1 is x plus 1. X plus 1 times by 1 over x plus 1. This x plus 1 with x plus 1 cancels and only we have 1. So plus 1. And this is for numerator. Now multiply x plus 1 in the denominator. X plus 1 times 1 is x plus 1. X plus 1 times this cancels with this, and then we have negative 1. So basically minus 1. And as you can see, the answer is x plus 2 over x. 1 plus 1 is 2, 1 minus 1 is 0. So in numerator we have x plus 2, in denominator only we have x. And definitely this method is the best method for this question. If you don't like this, you can add these two, subtract these two, then divide the numerator by denominator. I'll leave that method to try by yourself. Now look at this example. A plus b over a divided by b plus a over b. For this question, I will show you both methods to do this question. First, I want to show you the elimination method. Let's name it the elimination method. If you pay attention, we have different denominators. One of them is a, the other one is b. So, because we want to get rid of both of these denominators, so we have to multiply the numerator and denominator by an expression that helps you to get rid of all the denominators. So what would be that expression? AB. So we multiply the numerator and denominator by AB. So if we multiply the numerator and denominator by AB, then we have AB times A would be a to the 2b plus ab times b over a. Please pay attention. ab times by b over a with a cancels, and we have b to the 2. So b to the 2 here. What about the denominator? If we multiply ab by b, then we have ab to the 2. And if we multiply ab by a over b, this b with this b cancels, and then we have a to the 2. And this is the final answer for this question. If you like, you can write your answer in the form of, if you factor a b from numerator, then you have b times by a2 plus b. If you factor a from here, then we have b2 plus a. But really this answer is not much better than this, so you can leave it in this original form. But if you like, you can factor the numerator and denominator in this way. This is completely optional and it's up to you. Now let's do this question with the other method. So we want to simplify this with the other method, which is adding, subtracting numerators and then dividing numerator by denominator. First, we have to do a common denominator in numerator. Attention, denominator of this is 1, denominator of this is also 1. What would be the common denominator? The common denominator is a. Because denominator here is 1, here is a, the common denominator between 1 and a is a. Because we multiply the denominator of the first fraction by a, we have to multiply the numerator also by a. So we have a to the 2 over a and plus b. Attention, a to the 2 divided by a is again a. For denominator, again, if we do same thing, the common denominator is b, and then in numerator we have b2 plus a. So this is common denominator. Then we write numerator in the form of a2 plus b over a divided by b2 plus a over. Now we have a division between these two rational expressions. And we know that for dividing two rational expressions, we multiply the first rational expression by the inverse of the second one. And this equals to a2 plus b over a times by, we write the numerator, we times it by reciprocal or inverse of this, which is b over b2 plus a. Now multiply numerator by numerator, denominator by denominator. Because there is no common factor to cancel, so the answer would be a2 plus b times b over a times b2 plus a. If you attention, these two answers are the same. b times a2 plus b times a2 plus a times b2 plus a times b2 plus a. They are the same. Now look at this example. X to the negative 1 plus y to the negative 1 over x plus y to the power of negative 1. Attention that x to the negative 1 is basically 1 over x, y to the negative 1 is 1 over y, and x plus y to the negative 1 is 1 over x plus y. We know that when the power is negative, it means reciprocal of the expression. Now we want to simplify this. We can see that we have three different denominators. If we want to use the first method, then we have to multiply the numerator and denominator by an expression that can help us to eliminate x, eliminate y, and eliminate x plus y. What would be that expression? The expression that can help us to eliminate these things is x, y, x plus y. And of course, we have to multiply same expression in the denominator. We have to have x because to get rid of x. We have to have y because we want to get rid of y. And we have to have this because this helps to get rid of this denominator. Now, what we have for the numerator? In the numerator, if we multiply this by 1 over x, x with x cancels, then we have y times x plus y. So we have y times x plus y. And then if we multiply this by 1 over y, the y with y cancels, then we have x times x plus y. So we have x times x plus y. What about the denominator? In denominator, when we multiply this by this rational expression, this cancels with this, and then we have xy times 1. Xy times 1 is just xy. So in denominator we have xy. Now this equals to xy in denominator. If you pay attention, if you want, this is optional, you can factor this common factor from these terms. Then we have x plus y times y. From the first term we have y, from the other term we have x. But what is x plus y times y plus x? Attention, x plus y is the same as y plus x. So these two brackets are basically the same. So x plus y times y plus x can be written as x plus y to the power of 2. And this is the final answer for this question. You can use different methods, different approach for doing this question. But this was one method that I showed you here. For example, instead of multiplying numerator and denominator by this, you can start adding these two. Keep this here. Then after you added these two to each other by a common denominator, you can divide it by this denominator, and the answer at the end would be the same. X plus y to the 2 over xy. Let me show you that method here as well. So I'm going to erase this. So we want to use the other method, which we know we can use for simplifying compound fractions. What is common denominator between the terms in numerator? The common denominator between 1 over x and 1 over y is xy. xy, xy. From here to here, we multiply this denominator by y. So we have to multiply the numerator also by y. So we have y in numerator. For the other fraction, we have y already here. We multiply by x, so we have to multiply the numerator by x as well. So we have plus x here. And in the denominator, we leave it as 1 over x plus y. Now, if you pay attention, this equals to y plus x over xy. Y plus x, because the denominators are the same, we add numerator. Y plus x over xy. All of this divided by 1 over x plus y. We know that for dividing two rational expressions, we write the first one, we multiply by the reciprocal or invert of this, which we have then this expression. So we have y plus x over xy times y, x plus y over 1. We invert the denominator. Look at the numerator. Multiply numerator by numerator. Then you have x plus y to the 2. And in denominator you have xy. Same answer. And maybe this time this method works a little maybe better. Now look at this example. 1 plus 1 over 1 plus 1 over 1 plus x. The thing that is a little confusing when we see expressions like this for the first time is where we have to start. What we have to do with this? You have to start from the most inside part. But where is the most inside part? Definitely you cannot think to adding 1 to this, because this denominator is so complicated. You have to start from the easy part, from the inside. Where is the inside? This is inside of this fraction. This is in the denominator. And as you can see, this here, we have a relatively simple expression. 1 plus 1 over 1 plus x. So, we have to start from here. We add 1 to this fraction. We combine these two and we make basically the denominator a little simpler. Please pay attention. For simplifying this compound fraction, again you have two choices. You can think how to get rid of this by multiplying the numerator and denominator by 1 plus x, or you can simply add 1 to this by doing a common denominator. It's completely up to you. So you have two choices. You can think to multiplying the numerator and denominator by x plus 1. By doing this x plus 1 helps you to get rid of this, and you can simplify this. The other method is to add 1 to this. So it's up to you. Here, first I am going to use the common denominator method. I am not going to eliminate the denominator. After that, I will show you the other method. 1 plus 1 over, focus here. Attention, for 1 we can put a denominator of 1. What is common denominator between 1 over 1 and 1 over 1 plus x? Of course, the common denominator is 1 plus x. So we have 1 plus x, 1 plus x. Because we multiplied the denominator of this by 1 plus x, we have to multiply its numerator also by 1 plus x. 1 plus x over 1 plus x is 1. Original rational expression. And for the other one, simply we have a 1 in numerator. Now we have 1 plus 1 over, add numerator to numerator, 1 plus x plus 1 is x plus 2. And I prefer to write 1 plus x in the form of x plus 1 because the order really doesn't matter, so I don't like to write 1 plus x, I prefer x plus 1. Now, attention, this is simple. We have 1 divided by this. We know that when we have an expression divided by a rational expression, instead of dividing, we can multiply by invert of the denominator. So we have 1 plus 1 times y invert of this, which is this. So we inverted the denominator. And this is really simple. 1 plus 1 times this would be same expression, x plus 1 over x plus 2. Now here we have to do again a common denominator between 1 and this. What is the common denominator? Common denominator is x plus 2. Again, consider a 1 here. So x plus 2, x plus 2, x plus 2, and x plus 1 here. Add numerator to numerator, x plus 1, x plus x is 2x, 2 plus 1 is 3. And in denominator, yeah, we have x plus 2. And this is the final answer for this question. 2x plus 3 over x plus 1. Now let me show you the other method for simplifying this expression, which is trying to get rid of, to eliminate the denominator first. Maybe you prefer that method. It's not bad to see that method. It's a good practice. So here we are going to multiply the numerator, which is 1, only 1. Attention, this is the main fraction. So we multiply the numerator and denominator, which is this big expression, by x plus 1. And because we multiply numerator and denominator by at the same time by the same expression, we are not changing the original value of the expression. So don't forget we have that 1. So we have 1 plus. In numerator, we have x plus 1 because 1 times x plus 1 is x plus 1. Now multiply this. X plus 1 times 1 is x plus 1. X plus 1 times by this is 1. Because denominator x plus 1 with 1 plus x cancel each other, 1 remains. So we have what? We have 1 plus x plus 1 over x plus 2. Now here we do again as common denominator. X plus 2 over x plus 2 plus x plus 1 over x plus 2. And the final answer is x plus 2 here, and numerator is 2x plus 3. From here to here is same as the previous method. So as you can see, the answer is the same. The process is very similar, but sometimes one method is better than the other one. And the best thing is to learn both of these methods because it depends on the question, to the situation, to use which of these methods. Now look at this example. Examples like these appears especially in the calculus course. So it's a good practice to learn these type of examples. We have a compound fraction. You can use both of the methods that you have learned so far. Doing a common denominator for numerator and then dividing numerator by denominator. The other way was eliminating the denominators first. Here I prefer to use the second method. I try to eliminate the denominators. What are the denominators? As you can see, we have two things in the denominator, 1 plus x plus h and 1 plus x. So we have to multiply the numerator and the denominator by this. By doing this, what happens? In denominator we have h times by 1 plus x plus h times by 1 plus x. But what we have in the numerator? When we multiply this by the first fraction, this cancels with this, and then we have 1 times 1 plus x, which is 1 plus x. So in numerator we have 1 plus x minus, don't forget, we have this minus here, and this minus is for everything that I am going to write here. So minus this times by this cancels with this bracket, the first bracket remains. So minus of 1 plus x plus h. Don't forget to multiply the negative, the minus, to the all of the terms in the bracket. In the numerator, if you pay attention, we have 1 minus 1, which is 0. X minus x is 0. So in numerator only we have negative h. So negative h all over h times 1 plus x plus h times 1 plus x. If you notice, h is common between numerator and denominator. So the final answer is negative 1 over 1 plus x plus h times 1 plus x. So this h with this h cancels. And this is the final answer for this question. I hope this video was helpful for you to learn about adding, subtracting, multiplying, and dividing rational expressions, which is a very important topic in algebra, which is useful for more advanced course like pre-calculus or calculus or more advanced mathematics course. If you want to learn more about these topics and you want to see more examples, watch my other videos that I have for these topics. If this video was helpful for you, please subscribe in my channel and see you in the next videos.